So the video got cut off when I was in the middle of doing this problem. I'm just going to keep going. We were calculating the volume of this part of the cylinder, this part of the glass, which is the cylinder. So that's pi times 3 squared times 3. So that ends up being 27 pi. And it's cubic centimeters. That's the unit of the volume. So if the top part is 27 pi, the bottom part is 18 pi, that's altogether 45 pi cubic centimeters. And you can either leave it like that, or if you prefer to go ahead and multiply that out and round, that's the same thing as 141.37 cubic centimeters. Now, glass 3. The big trick about glass 3, we don't have to decompose the object. It is a cone, and it says the bowl of glass 3 goes down into the stem, so it's a full cone. The thing that we have to decompose about this are what are the important parts. The volume of a cone is 1/3 pi r squared h, but we need to remember that height is always perpendicular to the radius, right? So just like here, the height is perpendicular to the radius in the cylinder. Height is perpendicular to the radius in a cone as well. So they don't give us that height. So we need to kind of decompose the parts here. What we have is we have a right triangle right here. And that right triangle has a length of 7 on this side, but of 3 on this side. So we've got 3 centimeters and 7 centimeters right here. So we can decompose, we can imagine this is having a right triangle, and suddenly we're able to see, okay, well, the part that we need, we can use Pythagorean theorem on, right? A squared plus b squared equals c squared. And remember that in this case, the 7 is the c, right? So, and then the 3 could either be a or b. So 3 squared plus b squared equals 7 squared. And that means 9 plus b squared equals 49. So b squared equals 40. So b is the square root of 40. I'm going to go ahead and in this case round. So b is approximately 6.32, right? And then in order to get the volume, then we can just plug that in. So now we know that this is the height. So we're calling it b, but it's also here the height. So to do the volume here, then we say volume equals 1/3 times pi times the radius, and remember the radius is 3. So 3 squared, and then times 6.32. So go ahead, and there's no use in keeping pi here because we've already rounded. So just multiply the whole thing out. 1/3 times pi times 3 squared times 6.32. 59.56. So the radius is approximately, and now we've rounded. So, and notice I forgot to use the rounding symbol here. I should have used the rounding symbol there, right? So radius is, the volume is approximately 59.56 cubic centimeters. Okay, so now if we're looking on the second page, this second page says find the height of the liquid in glass 2. So glass 2 right there, when it's half full, and show how you figure it out. So here, if we're looking at glass 2, a lot of folks just said, oh, well, if I go up 3 centimeters, that must be half full because that's half the height. But again, you're thinking that the height is proportional to the volume, and that's not true. Here we have this shape on the bottom that's not the same as the shape on the top. So we in fact know that the shape on the bottom, right? We know that this shape on the bottom is actually only 18 pi cubic centimeters. While this shape on the top, right, is that 27 pi cubic centimeters. We just figured that out in the last one. So, and altogether that's 45 pi, right? But half of that, if we were to fill the volume up to half of that, that would only be 22.5 pi, right? So 22.5 pi cubic centimeters is when you get to the halfway point. So we're going to fill the glass up to 3 centimeters, right? A height of 3 centimeters, and that's only 18 pi. We still have another 4.5 pi cubic centimeters to go. There's still that much volume left to fill, and we need to do that in this cylinder. So we need to figure out how much higher do we need to pour into the cylinder to get that extra 4.5 pi, right? So the question becomes, now that we understand that, the question becomes, what height of a cylinder with a radius of 3 centimeters, because the cylinder has 3 centimeters, so we know that much, will give me a volume of 4.5 pi. That's the question we need to ask. And we have this formula, volume of a cylinder is pi r squared h, right? So we know that we can use this formula to figure that out. So at this point, my strategy would just be to plug things in, to say, well, I know the volume. I know that's going to be pi. I know the radius is 3 squared. I just don't know h. So see, now that I've plugged these things in, there's other strategies you could use, but the point is you're trying to find this height that with a radius of 3 that will give you that volume. So I'm just going to go ahead and 4.5 pi equals 9 pi times h, divide by 9 pi on both sides. And notice by working with the pi, I actually just get to cancel that out. So 4.5 divided by 0.9 is 0.5. So the height that I need to go into this cylinder is 0.5. I need to go an additional 0.5. So I need to fill the hemisphere up the 3 inches, but I need to go an additional 0.5. So that's 3.5 centimeters. So the total height going up is 3.5 centimeters. The last question here, glass 4. So this is a glass 4. It's shown in the diagram. And we need to figure out which formula gives us the volume of glass 4. So there's a couple things happening here. I will say that one of the assumptions that they make, that they don't tell you, is that this right here, they split in half. So the height is actually split in half. It doesn't have to be that way, but in this case, they do split this height in half in order to make this. So that is an assumption there. So which formula is going to give you these? So we're going to decompose the objects. We've got a D, right? We've got this cylinder right here, and we've got this cone, right? So automatically we know the formula for the cylinder is pi r squared h, and we know the formula for the cone is 1/3 pi r squared h. So these are pretty similar. We're going to be needing to add these to whatever we come up with together. So if you look here, we're going to need a pi, we're going to need an r squared, right? And the thing is that the r is the same thing as d divided by 2, right? So r here is d divided by 2. So this is going to be the same in both of them. This is going to be the same in both of them. The thing that is going to be a little bit different is the h, right? So automatically, if I'm looking here, there's no reason that that's going to lead me by adding these two things together to square an h, right? So these two I can automatically cancel out, right? Which leaves me with these two. And then the question is, am I going to be squaring the d or not? And that's the only difference, right? But if you think about it, the radius is d over 2. So if I put this in here, pi times d over 2 squared times h, yeah, I'm going to end up needing to square the d. So even before I go ahead and finish this formula exactly and calculate it myself, I can just tell I'm going to need to be squaring that d. I'm going to need to just be multiplying by the plain old h. So somewhere this is going to be, I can tell that this is going to be the answer because I can just cancel out these other 3. But if I were going to go ahead and finish this, notice that I need to, for the cylinder, I have pi times d over 2 squared. And then remember, for the cylinder, this is now h over 2. So I'm going to be multiplying by h over 2 for that because I've cut that height in half. So the cylinder has d over 2 for the radius and h over 2 for the height. Same thing here. The cone has d over 2 for the radius and h over 2 for the height. So I can plug those in. So I need to add 1/3 times pi times d over 2 squared times h over 2, right? So now I just need to kind of do any simplification here. This is really pi times d squared over 4 times h over 2. And this is still plus 1/3 pi d squared over 4 times h over 2. And then pi times d squared h over 8 plus, and then if I multiply all these down here, that would be over, so pi times d squared h over 24. And then if we add those two together, 1/8, this is basically saying 1/8 of this plus 1/24 of this, so 1/8 plus 1/24. That's the same thing as 3/24, which equals 4/24, which equals 1/6. So you can see why that's 1/6 d squared h. However, that's the long way to do all of that. If you notice, explain how you can tell just looking at the forms of the expressions. Did you need to go through all of this? No. Just by looking at the forms of the expression is what we did earlier. We know that we're going to need to square the d because that's related to the radius, and we know we're not going to square the h because that's just related to the height. So that's why you would be able to tell that this was the answer even if you didn't go through all of this.